Good afternoon, good evening, good morning, whenever you're watching. Thank you for watching our video of lecture today. Today's topic is 2.17 Reactants and Products. Okay, I am here working with fifth period again. They are little angels, so that's how come I always pick them. Okay, I never have a problem with them. All right, so does anybody, who's going to be reading for me today?
I'll do it.
Thank you, Mr. Oscar. That's very nice of you.
Over the last few decades, computers have proven to be extremely useful tools for organizing and processing information. You put data into the computer, such as structural parameters of a compound, and your output can be a detailed diagram of how the molecule looks in 3 dimensions. The computer and its programs transform input data into a useful final product.
Right. Now we have these fancy programs that all I have to do is put a little bit of information and it'll pop up an element and it could show me how it looks at the molecular level. It could tell me useful information about that element or compound. Just depending on what you need, what information you need, right? Every tax season you go around, you give them how much you made, you give them all this information about donations that you have done and stuff like that, and they create the form, and it does mathematically calculate how much I have to pay in taxes every year. Okay, that's just another example of information that's inputted and calculated and spit back out so that I can know, hey, how much do I need to pay Uncle Sam so I don't get in trouble every year, right? If you don't pay your taxes, you get in trouble. So I need to make sure that the information that person is putting into the computer to calculate my taxes is correct. Because do I want to pay extra more than I have to pay? Of course not. Nobody wants to pay more than they have to, right? If Oscar is gonna go and buy something special for his girlfriend or his friend or his mom, he wants to make sure that he is paying exactly how much that product cost. He doesn't want to have to pay more. So when that person puts in that amount that Oscar has to pay into the computer, he's going to be watching and making sure, okay, that's the correct amount. That's the correct amount for taxes. Okay, that's good. I'll pay now. But if he sees that a higher amount has been entered, he's going to say, hey, that's not right. This thing costs $20. Why are you putting that it's $30? Right? Because Oscar does not want to overpay. So he's going to be very careful about what that person is inputting into the computer. Right, Oscar?
Yes. Why is there only 8 people missing?
All right, so today's topic is chemical equations, chemical reactions, reactants, and products. So that's what we're going to be talking about today. First topic is chemical equations. What is a chemical equation? All it is, it describes what's going to happen in a reaction, okay? So the reaction between zinc and sulfur can be shown in what is called a chemical equation. In words, we could write the reaction as zinc plus sulfur produces zinc sulfide, right? It's the same thing that I just read, but now I'm being specific. The reaction between zinc and sulfur. Okay? Though that's a sentence, right? You're telling me that I have to show an equation or a reaction where these two elements are reacting. A more convenient way to express chemical reactions is to use symbols and formulas of the substances involved. For example, you're going to be using Zn for zinc, right? Zn is the symbol for zinc. Capital S, is the symbol for sulfur. And if I'm talking about zinc sulfide, the compound, that formula for that compound is going to be capital Z, small n, big S. Okay? this is exactly what you will see in our reactions in future assignments from now on. I'll tell you the name, I'll tell you what it produces, and you have to be able to write these formulas and identify these substances. The substances to the left of the arrow in a chemical equation are all called reactants, okay? On the left, just like Beyonce says, to the left, pack your bags and go to the left, whatever she says. Well, everything on the left side of your arrow is a reactant, okay? A reactant is the substance that you start your chemical reaction with, okay? Before the reaction has occurred, whatever substances you have, that those are your reactants. In the case of making the zinc sulfide, zinc and sulfur are your reactants. The substances that are on the right side of your arrow are called products. You always have to remember that a product is what results after a chemical equation or reaction has occurred. Once those substances have chemically combined and the reaction is complete, you end up with your products. That's how come, I don't know if you heard me, but I was saying zinc reacts with sulfur to produce zinc sulfide, right? To produce means I'm making products of this reaction. In the equation above, zinc and sulfur are your reactants that are chemically combining to make your product of zinc sulfide. Questions about that, guys? Questions about reactants and products? Irvin, anything? No questions? Okay. In the equation above, sorry. There is a standard way of writing chemical equations. All reactants are written on the left side of the equation. Products will always be written on the right side. Okay. And in the middle, what divides my reactants from my products is that produce sign, that yield sign, that arrow. Okay. We call it an arrow. An arrow usually points from your reactants to your products and indicates in what direction the reaction is processing. In the example that we're talking about, zinc and sulfur, it tells you that everything, your reactants on the left are moving to the right and creating that compound. There are certain symbols that we use that are written on top or on bottom of your arrow that indicate what is going on in your reaction. Okay? Sometimes you're under pressure, so you might see a P. Sometimes sometimes you'll see the symbol of a triangle, right? Anytime you see this triangle right here, like you can see right here in the sentence, this triangle is called delta. In math, it's called delta. And in chemistry, we call it delta also. Now, this delta indicates that this reaction or the reaction is being heated. So if you see a little triangle on top or on bottom of your arrow, that just means in order for the reaction to happen, heat is applied or heat is being used. All right. The presence of the arrow also indicates the reaction goes in one direction under those conditions. Okay. Now, will it always have an arrow going to the right? No. There will be some reactions where you have an arrow that goes in both directions. All that means is that this reaction is reversible, meaning it can go forward to the right or it can go back to the left. Okay. And that only happens in certain reactions, so you will not always see that. Okay. Questions about directions, questions about symbols and special circumstances? No? Okay, let me know or stop me if you have any questions. There are a wide variety of reactions possible. Elements may form compounds, as seen in the reaction above. Compounds may form elements, like water breaking up into hydrogen and oxygen gas. Or compounds may combine, break apart, or rearrange to form new materials, okay? And we're actually going to talk about those different types of reactions really, really quick. All right, I'm going to go into Google Classroom with my iPad, and we are going to, I'm going to stop sharing because I'm going to share with my iPad. I'm going to mute myself for a second so it doesn't echo when I log in. All right, it's not echoing, right? You guys don't hear an echo? All right. No. Okay, perfect. Alrighty, so I'm logging into Google Classroom with my iPad. Oh, did it start? No, I kind of pushed stop. All right, you guys should be looking at my iPad now. We're going to go into something called Notability. I need to delete some of those. Alrighty. So the first reaction that we're going to talk about is called I hate writing with this pen. Synthesis reaction. And you do not have to write this down. Just pay attention, okay? Synthesis reaction. Oops. RXN is just a short abbreviation for reaction. Synthesis reaction is when a boy, Albert, likes a girl and they become a couple. Okay? That is synthesis reaction. This is like the example that they gave us in today's reading when they make zinc sulfide. And okay. Second type of reaction is the opposite of a synthesis reaction, guys. Decomposition breaks things apart. So think of Albert and Bonnie. Oops, no, that's not what I want. Breaks up because Bonnie saw Albert walking with somebody else. So here, an example would be water breaking up into hydrogen gas and oxygen. Another type of reaction is known as single displacement reaction. So this is when you have elements rearranging or doing an exchange. Okay. So if I have Albert and Bonnie, that's kind of like when the ex-boyfriend Carlos comes back from out of town and steals Bonnie because he knows what she likes. All right, so kind of like salt and magnesium. Oops. Doing a switcheroo. Magnesium steals chlorine and sodium is left all alone. Okay? That is the third type of reaction. In the fourth type, this is the one where everybody goes to the dance. I always say, okay, so you have, first off, it's called a double displacement reaction. Okay? So that's kind of when you have two couples going to the dance like Albert and Bonnie, Carlos and Daniela. Well, Daniela can't dance. All right, but Bonnie loves to dance. So guess what's going to happen? Carlos is going to be dancing all night with Bonnie, and Albert's going to get left behind with Daniela because they don't know how to dance. Okay? If you want an example, that's like salt plus magnesium iodide, and we switch them around. Magnesium goes with chlorine, and sodium ends up with iodine. The last type of reaction is the one that my students like the most because what they say is that it's easy to identify. Okay. Oh, what happened? I erased that. Okay. These are real easy. This one is easy to remember because, and I'm going to tell you why. Combustion reactions always involve three compounds. You'll always see these three compounds. So you'll have any compound mixing with oxygen, and it will always make water and carbon dioxide. Now, why do people like it? Because this guy, and this guy are always in that place. Okay? This part of the reaction never changes. These can switch. Other than that, it'll be the same. Okay? These two can switch places, but everything else, it'll still be on the right side of your arrow. All right? Okay. And I don't even know if I don't think it recorded that, but I will upload the notes on this. Okay, guys? Don't worry about it. Okay. Don't worry. If you're listening to the recording, don't worry about those types of reactions. You don't need them in order to answer the questions. Now, let's watch this video. Oh, I'm not sharing, am I? Ugh, I always forget. Okay. Let me share. All right, you should be able to see now. Oh, let's restart it. Okay, there she is.
Talking of cooking, just in time, perfect. Another chemical reaction has just happened here.
Anytime you go into your kitchen and you have to add heat to something in order to finish the process so it's ready to consume, you are doing some type of chemical reaction every single time.
Chemical reactions are useful in cooking. They help improve the taste of food. Cooking and chemistry have quite a bit in common. The starting materials in a chemical reaction are called the reactants. These react with each other to form a completely new substance, the product.
Sorry, I meant to stop it right. Oh, hide. I meant to stop it here. So, if you have ever baked a cake, if you've ever made brownies, if you've ever created a very difficult dinner, like me, my husband and me, we make this salmon with some wine sauce, Now, the salmon is easy to make. All I need is just lemon juice and salt and pepper. But the wine sauce is really complicated. I need to go buy evaporated milk. I need to go buy condensed milk. I need to go make sure I have some cherry wine. I have to go and make sure I have all the spices. It's quite complicated when I make it. So we don't make it often, but when we do, I need all of these materials, these substances, and I need to bring them together and I need to mix them and heat them at a certain time, because if I don't, if I'm missing one of these substances, it's not going to come out correctly. I have to always make sure that I am following the recipe. Anytime you bake a cake or you make cupcakes or you make brownies, you're going to be bringing different substances together. You're going to be bringing in some flour. You're going to be bringing in some eggs. You're going to be bringing in some oil, right? And you're going to mix them all together and you're going to pour it in the pan. And you're going to throw it into the oven. And it's going to take some time. All of those substances that you mixed before you blended it, before you threw it in the oven, all of those are your reactants. Okay, same thing in chemistry, right? Everything that you have before your reaction has occurred are your reactants. Okay, now once you've mixed them up, once you've heated it, the mixture, it comes out completely different. You have undergone a chemical change or a chemical reaction that has made all of that stuff that you mixed into this delicious, warm cake. That's so, and then you put the frosting and it tastes so good. And you sing happy birthday to whoever you baked it for or whatever.
To form a completely new substance, the product.
So this is where whatever comes out of that heat, whatever comes out of that oven is considered your product. It's warm, it looks different, it tastes different than whatever it is that you had before your reaction occurred.
As you can see, products have very different properties to the reactants. This cake is a lot firmer, tastes a lot nicer than the individual reactants. It's a different colour too. Not all chemical reactions need heat energy to make them happen. Take some bicarbonate of soda, add a little vinegar, and watch.
So here you have a mixture of baking soda and vinegar. We do a similar reaction, but we do it in a bag so you can see. We can trap that gas that's being released that you're going to be seeing right now.
It's another chemical reaction. This time, one of the products is a gas, enough to inflate a balloon. Without chemical reactions, it wouldn't just be our food that would be boring.
Okay. Any questions, guys? Any questions? So, in summary, a chemical equation describes a chemical reaction. Reactants are your starting materials and are written always on the left side of the equation or the left side of the arrow. Your products are what you end up with after the reaction has occurred, usually on the right side of the equation, or you'll see that arrow pointing to them. Okay? You have 4 questions that you have to do today. Well, four is 2 parts, so it's like 5 questions. What is a reactant? What is a product? What does a chemical equation do? In the reaction of sodium plus water, producing sodium hydroxide and hydrogen, question A says, what are the reactants? And question B says, what are the products? All right. Let me know if you need any help. You can email me. You can reach out to me on my work phone. My number is 600-5471. Let me know if you need any help, guys.